Okay, so we want to find the derivative of the function f of x equals x squared minus 3x minus 4 at the point where x is equal to 5. Well, we're going to use the definition of the derivative, which says that f prime of c is equal to the limit as x approaches c of f of x minus f of c all over x minus c. Well, let's adapt this because we want it to be, we want our c to be 5 here. So f prime of 5 will be the limit as x approaches 5 of f of x minus f of 5. Okay, so what we're doing here is we're substituting the given value of x for c. We don't substitute for x, we substitute it for c, because c is the fixed value of x. Well, if f of x, we'll just do this off to the side a little bit. If f of x is equal to x squared minus 3x minus 4, then f of 5 will be 5 squared minus 3 times 5 minus 4. So that'll be 5 squared is 25 minus 15 minus 4, which is going to be 6. Okay, so we're going to do that again in a moment. So we'll have f prime of 5 is now equal to the limit as x approaches 5, f of x, that's x squared minus 3x minus 4, and then we have the minus 6 that we just calculated. Okay, and that's going to be over x minus 5. So if we go ahead with this a little bit further, we have the limit as x approaches 5 of x squared minus 3x minus 10 over x minus 5. Now we can save ourselves some time here. If we plug in 5 on the top, we're going to get 25 minus 15 minus 10, which is 0, and on the bottom we're going to get 0. Okay, so that's going to be 0 over 0. Now you have a couple of options here. You can use L'Hopital's rule if you like, or you can just try and factor the top line, whichever you prefer. Let's use L'Hopital just to get a little bit of practice with it. Sounds rule. We could also factor. Well, if we use L'Hopital's rule, and remember, as far as we're concerned this year in Calculus AB, L'Hopital's rule is really only of use to us for limits that give you 0 over 0 by substitution. So remember what L'Hopital's rule is. It's differentiate the top and the bottom, the denominator and the numerator separately. We're not going to use a quotient rule. It would be the limit of 2x minus 3. And on the bottom we would just have derivative of x is 1. And now if we do that by substitution, that would be 2 times 5 minus 3 over 1, which is equal to 10 minus 3, or 7. So that's telling us that f prime of 5 is equal to 7. Now that is using the definition of the derivative at a point. Now, we learned a long time ago, it seems like now, how to differentiate using shortcuts. So let's go back and try this problem now using shortcuts. Let's scroll down here for a second to see what the problem was. It was if f of x equals x squared minus 3x minus 4, find f prime of 5 using the definition of the derivative. Well, now let's use the traditional method of the shortcut. F of x, x squared minus 3x minus 4. So, using the shortcut, we have f of x is equal to x squared minus 3x minus 4. So f prime of x would be 2x minus 3, and f prime of 5 would be 2 times 5 minus 3, which is equal to 7. Okay, so the same answer, which is a relief, because if we're trying to find something with a single answer, it would both need to be exactly the same. But using the shortcut is much, much quicker. Now, remember, the shortcut doesn't have much sense to it. It is purely a shortcut. There's not much logic to deriving it as far as we've seen. Obviously, there is some logic somewhere along the way, but for us, it's hidden right now. And if we use the definition of the derivative at a point, the question takes much, much longer. But this is the way that it would, that calculus would have developed. It would have developed this longer method first, and the shortcuts would have come later. So now we can do it both ways. The good news is that you won't be asked to do them in the original method. You won't be asked to do them using the definition of the derivative, but I think it's important that you see it. Okay? Alright. Thanks for watching.